Welcome, physics students, to our video about Newton's third law. In this video, we're going to look at what Newton's third law is. And as part of that, we'll look at action-reaction pairs and examples of action and reaction forces and field forces as well. So what is Newton's third law? Newton's third law essentially states this. If two objects interact, the magnitude of the force exerted on the first object by the second object is equal to the magnitude of the force simultaneously exerted on the second object by the first object. There's a typo. Should say object 2 exerted on object 2 by object 1. And these two forces are opposite in direction. So an easier way to rephrase this, and you've all heard this, for every action, there's an equal and opposite reaction, meaning equal in magnitude, opposite in direction. So Isaac Newton realized that a single isolated force cannot exist. Instead, forces always exist in pairs. And the way they exist in pairs is often termed action-reaction pairs, is what we oftentimes call them. The way we think of action-reaction pairs would be the action force would be the force object 1 exerts on object 2. The reaction force would be the force that the object 2 exerts on object 1, and both forces occur simultaneously at exactly the same time. Here's just a little example. The action force here is the force of air rushing down. The reaction force would be the balloon going up. That would be an example of an action-reaction pair, and both forces are occurring at exactly the same time. Because both forces exist simultaneously, either force could be called the action or the reaction. So you could flip. This could be the reaction, this the action. They're both occurring simultaneously. It's just that one is the action, one is the reaction. They're not necessarily specifically designated such. Here are just more examples. Swimmer's hand pushing against the water, whereas the opposing force would be the water pushing against the swimmer's hand. Here would be an action-reaction pair, the boy's feet exerting force on the boat exerting force on the boy's feet. More examples. Rocket engine thrust is a really good example of Newton's first law. The exhaust flow exercising a force out the back of the engine, and the engine being pushed forward is the opposing force. Here would be another example. The direction of the bullet and the direction of the recoil would be an example of an action-reaction pair. Here, force of finger, force of wall, action-reaction. Here, just walking is a wonderful example of an action-reaction pair. We have the force exerted by the foot on the ground and the force exerted by the ground on the foot. Each force in an action-reaction pair acts on a different object. That would be something to keep in mind when you're thinking about this. Action and reaction forces do not always cancel each other out. So here's an example. What if we have a hammer? Hammer is exerting force on a nail, this direction. The nail exerts a force on the hammer, this direction. If the force of the hammer on the nail is greater than the force of the nail on the hammer, we will have the nail will be moving, right, this direction. There will be a change in motion. This net external force is what drives the nail into the wood or the material or whatever is happening there. So when action-reaction forces do not cancel each other out, we will have some change in motion. It's important to remember that field forces also exist in pairs. So I've been talking about contact forces, but when we think about field forces, they also exist in pairs. For example, if we have a an object in free fall, this ball. This ball is exhibiting a force on Earth, just as the Earth is exhibiting a force on the ball, the force of the gravity of the Earth. So as the falling object accelerates toward Earth, Earth is also accelerating toward the object. You could think of it in that way. This may sound a little strange, and we know that because the mass of the Earth is so entirely enormous, we don't see much of an acceleration in that direction. But indeed, field forces do exist in pairs, and both the action and the reaction are happening between objects experiencing field forces. So this should be a nice short video for you, all about Newton's third law and examples of that. If you want some advanced ideas, create your own situation and identify or diagram the action-reaction pairs of forces that are present. Does motion result, and why or why not? And I look forward to seeing what you come up with, and we'll see you in class.